Hi everyone. So in this video, we're going to work through a pure maths year 12 question from the AS 2018 paper. And this question is on calculus. So there is a mixture of integration and differentiation with this question here. So figure 4 shows a sketch of part of the curve C with the equation y equals 32 over x squared plus 3x take away 8, where x is greater than 0. So the point P, which is 4 and 6, lies on the curve. So that there is 4 and 6. And then the line L is the normal to the curve at the point P. So we have a normal line there. So that means differentiation will be involved because remember, to find the equation of the normal line, you need obviously the gradient of the normal line, and that means you need the gradient of the tangent. So that will involve differentiation. Now, the region R shown in figure 4 is bounded by the line L, the curve C, and the equation x equals 2. So that vertical line is, of course, x equals 2. Now, we want to show the area of R is 46, and solutions based entirely on graphical or numerical methods are not acceptable. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Okay, so how will we go about trying to get this area R? Well, obviously we've got this point P there. And what you may be able to notice is if we just divide this region R into two separate parts, so part 1 and then this triangle is part 2, this will help us get the area because this area of 1, this region 1, is the integral of the curve. So it's the integral from x equals 2 to x equals 4, because remember the x value of p there is 4. So this is 4. So the integral from 2 to 4 of the curve C. So in other words, 32. And what I'll do, I'll use, or I'll write this down in index form. So x to the power of minus 2. And then you have 3x and then minus 8, of course, with respect to x. So that's the first area. And then the second area is, of course, it's going to be a triangle. Okay, so this is just half base times height. Now, we don't know this base yet of the triangle. We don't know this length because at the moment we don't know this missing length there. Let's just call this, let's call it y. Well, no, let's not call it y. Let's just call it capital X. I'm going to call it capital X there. I just don't want to use lowercase x because we're already using lowercase x for the integration. I'll call this capital X. There we go. So the area of that triangle is going to be half, and then the base is capital X take away 4, and then multiplied by the height of the triangle, which is 6, because of course the y value of p is 6 times by 6. So what we just need to do is we need to find out this value of x, capital X, and then we can go ahead and find the area just by using the integration for part 1 and then the area of the triangle for part 2. So finding x, let's just write this down here, finding capital X. So we need to know the equation of this line L. So we need to find the x-intercept of L. So this line L, so I'm going to write that L again a bit neater. There we go. So this L again is the normal line. So remember, the gradient of the normal is the negative reciprocal of the gradient of the tangent. We're going to need the gradient of the tangent. So we're going to use dy by dx to find gradient of the line or the tangent to the curve, tangent to curve at point P. So we're going to do dy by dx, so differentiating our curve, dy by dx. So that's differentiating 32, and then again, I'll write this in index form. So 32x to the minus 2 plus 3x minus 8. So this is going to give us, so bring the power to the front, take away 1 for the power. So minus 64x to the minus 3, and then plus 3, like so. So the gradient at this point P, we're just going to sub in x equals 4, because remember the x value there is 4. So now sub x equals 4. So that therefore means gradient of tangent at P is equal to minus 64 times 4 to the power of minus 3 plus 3. So let's just write this down here. So that means that gradient will be minus 64 over 4 cubed, and 4 cubed is also 64 plus 3. So this will be minus 1 plus 3, which is going to be 2. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. So the gradient of the tangent is 2. So that means the gradient of normal, negative reciprocal will be minus 1 over 2. Perfect. So we know that the equation of L is going to be y equals minus 1 over 2x and then plus c. Now, if we can just get the plus c, that means we've got the full equation of the normal, and then that means we're going to be able to work out what this missing capital X value is going to be over there. Okay, so to do that, what we can now do is we can now sub in the coordinates of P. So sub in P, which is 4 across and 6 up. So 6 is equal to minus 1 over 2 times 4 plus c. So 6 is equal to minus 2 plus c. So therefore the c is equal to 8. So therefore the equation of L is y equal to minus a half x plus 8. Now you could also use the formula y minus y1 equals m x minus x1. That's fine as well if you want to use that, or if you prefer using that, that's absolutely fine. So that's our equation there. So now then, again, we want to find this capital X there. So the y value here at this point is obviously 0. So let's just sub in y equals 0. So now we're going to sub y equals 0. So we end up with 0 is equal to minus a half x plus 8. If we move over the half x to the other side, half x is equal to 8, and then times by 2, x is equal to 16. So therefore this capital X value would be 16. So now then we can say that the region R, or the area of R, sorry, let me write that again, area R, let's just write that there, area R. So that's going to be, again, the integral from 2 to 4 of the curve. So 32x to the minus 2 plus, I think it was 8x. Was it 8x? Sorry, 3x. Sorry, 3x. Take away 8. 3x, take away 8. and then plus the area of the triangle, so half, and then base times height. So now we know that this missing value there is 16. So it's 16 take away 4 times the height of 6. So 16 take away 4 times 6. So this area, now let's do the integration first. So the area will be, so add 1 to the power, divide by the new power. So 32x to the minus 1, divide by minus 1. Then it will be 3x squared over 2, and then a minus 8x for the last term from 2 to 4, and then plus the triangle. So this will be a half of 6, so 3 times by 12. So 12 times 3 is 36 for the area of the triangle. So now then we can just simplify our integration here. So minus 32 over x, this first term would be, plus 3 over 2x squared minus 8x, and again plus 36. So if we just sub in the 4 first, the top limit first. So that's going to give us minus 32 over 4 plus 3 over 2 times 4 squared, which is 16, and then minus 8 times 4, so minus 32. Perfect. And then plug in 2, so minus 32 over 2, plus 3 over 2 times 2 squared, which is 4, and then minus 2 times 8, which is 16 there, and then again plus the 36 at the end there. So then this is going to give us, so we've got minus 32 over 4, that would be minus 8. And then we have 3 over 2 times 16. That would be the same as 3 times 8, which would be 24. Then we have a minus 32. And then we're going to minus everything inside the second pair of brackets. So what we'll do is we'll say that this is plus 32 over 2, which is plus 16. So plus 16 for the next one. Then we've got 3 over 2 times 4, which is the same as 3 times 2, which is 6, but minus that, so minus 6. And then we have minus 16, so plus 16 plus 36. So now then we've got minus 8 plus 24. Well, that's going to be 16. So you got 16 and then minus 32. So those three terms there will give you a minus 16. We then got a plus 16 next, so those will cancel out. You then got minus 6 there, plus 16 plus 36. Now, of course, minus 6 plus 16, that's going to give you a 10. So you have 10 plus 36, and of course 10 plus 36 is 46, and that is the answer we needed. I think it was, yep, 46. That's what we needed to show, and we've got our final area there. If you do have any questions, do feel free to drop a comment below, but hopefully you are happy with everything we've done there in this question.